Hi, this is Chris from Laptastic, and today I would like to give you an introduction to the free video analysis software Tracker. Tracker allows you to study the motion of an object simply by making a video and a few clicks on the computer. If you look at the website, we see Tracker is available for all platforms, for Windows, Mac and Linux. There's even an online version of it, so why not give it a try? So to begin with, I'd like to use a short clip I took with my cell phone showing a car moving at constant velocity. When I take a video, I pay attention not to get too close to the scene. At the borders of the frames, distortions might be present, and these might affect the results. Rather take a few steps back and use the zoom function. For the same reason, I place the camera on the same level with the target. You don't want to look down or up onto the scene. And obviously the video should not be shaky, so try to keep a steady hand or use a tripod. Okay, now let's get started. I drag and drop the video into Tracker. This is version 6.1.3 and the video is in a MOV format, and you will see, at least on my computer, Tracker has problems with this format. Loading the video takes a while because I did not cut it before, something I would recommend you to do. Okay, now the video has loaded and I jumped to a moment where you can see the car, and if I now hit the play button, you see this odd behavior I mentioned before. You see the car jerking around. That's not my usual driving style. That's a problem with the MOV format, and what I do to get this straight is to upload the video to an online conversion service and turn it into an MP4. I never had problems with the MP4 format. Okay, now this is the MP4 file. Let's give a quick look at the player section here below. This is the play button. I can, of course, grab the slider and jump ahead. I can do single steps forward with this button. I can do single steps backward with that one. And I can jump back to the beginning using this button. If I hit the play button again, we can focus on the lower left. There you see a red counter. That's the frame counter, and you clearly see this is not 30 frames per second, this is not 60 frames per second. That's slow motion. So the video is actually in slow motion. I can show you if I drag the slider here and hit the play button. You see me in slow motion. Now those two little black triangles here and here are very important. They allow you to limit the video to a region of interest. I take this little black triangle and slide it up to about here, where the car is entering the scene. Okay, about here. I could do the same with the second triangle that delimits the end of the video. However, I prefer using this button, the clip settings button. I can also go to video clip settings. In both cases, this little dialog pops up. In this dialog, I can here enter the starting frame number, 2650. I can enter the end frame number, 2720, so that's 70 frames. You see the step size is 2 at the moment. If I put a 1 here, that means the Tracker is going to show me every one of those 70 frames. If instead I put a 2, I will see 35 frames, and 35 is okay. That means at the end in the analysis I will have 35 data points. Okay, I hit OK. And now you see we are at the moment the slider is at the end of this region of interest, I hit this button, jump back to the beginning, to new starting point, and hit the play button. Now that's the part of the video I'm interested in. Tracker will give you the distances, the velocities, the accelerations in standard units. In order to do so, it needs an image scale. So we have to present Tracker with a known distance in one frame. In my case, I've measured the wheelbase, the distance between two wheels, and this distance is 2.5 meters long. Usually you can simply put a yardstick somewhere into the scene. However, be careful. This yardstick has to be at the same distance and in the same plane where the moving object is. I jump to a frame where I can see the wheelbase. Now I hit this button and say New Calibration Stick. This blue thing here is the calibration stick. In order to increase precision, I now zoom in. I go to 100%. Now I drag the ends of this calibration stick to the center of our wheels. And now this distance is 2.5 meters. So I enter 2.5 here. And that's it. I can now hit the play button, the car moves on, but Tracker knows that this distance is 2.5 meters. That means that I can hit this calibration tool button again, hide this tool, but it's still there. Next, I need a coordinate system in the plane of motion. Let me first zoom to fit. And now I hit this button to bring up the coordinate axis. And you see I can drag the origin around. Now I want to place the origin on a feature that I'm going to track, and I want the car to move along one of the axes. So let me jump to the start frame. Okay. Now I drag the origin on the feature that I'm going to track, and I decided to track the door handle. So again I zoom in 100% and place the origin exactly on this remarkable feature that I'm going to recognize on all the other frames as well. Okay, now let's look at the end frame. I jump to the end of my region of interest of this clip, and I give a look at the door handle, and you see, okay, the coordinate system is slightly off. The x-axis is too high, it does not go straight to the door handle. That means I have to rotate the coordinate system. There are two ways of rotating the axis. I could go back to the origin and find this tiny little line, and if I grab it, I can rotate the coordinate system. But you see, that's not exactly comfortable, so I choose another method instead. I'm going to change the angle up here. At the moment the angle is 0 degrees, which means that I try with 1 degree, and I see, okay, the axis has rotated, but too much. I try half a degree. Almost there. I try less, 0.4. Yeah, 0.4 is good. So you see, the ground probably was not perfectly level, or maybe the tripod wasn't, but now my coordinate axes are good. I zoom again to fit. So this is the motion. This axis should show the motion of the car. I jump back and hit the play button, and you see the door handle is exactly moving along this coordinate axis. Now that's good, I can hide the coordinate axis. Now that's enough of the preparations. I am now ready to track the door handle. In order to do so, I press this button, track. I say I would like to have a new track, and I choose point mass. You see the table and the diagrams pop up. I go to zoom level 100%. I go to the first frame of my video, and now it's the time to click on the door handle. However, it's a shift click. So I press shift, and you see the cursor will change, and then you can click on the feature you want to track. Automatically the next frame comes up and I can click again. Once more, once more, once more. You remember it was 70 frames, but since I selected step size 2, Tracker is going to show me 35 frames. So that means I have to do 35 clicks now. And that ends then up with 35 data points in the diagrams in the tables. Okay, that was the last click. I can jump back to the beginning again. I say zoom to fit, and if I press the play button, you see how the data points perfectly match the movement of the car. Okay, if now I see that I accidentally made a mistake, I can always go back and move one of these data points around. So for example, I could say number 20 is not well placed, let's put it back exactly there. Yeah. Okay, what's next? Now I would like to show you an alternative to this tedious clicking on the door handle, because actually for this video at least, Tracker can do this by itself. The feature is called Autotrack. But first let me change the step size back to 1, because I mean, if it's Autotrack, it can as well do all the 70 data points we have. So let's add a new track, new point mass, and say here, click Autotrack. Then a new dialog comes up and it says Shift Control click on the feature I want to track. Let's jump back to the first frame, find our door handle, and let's do Control Shift click. You see the cursor is different again, and I click on the door handle. Now Tracker recognizes this feature and looks for it in the other frames as well. I can now simply say search for this feature, and there it goes. That's it. Okay, close, and there we have it. Our graph is now full of data points. Okay, what have we got here? We see that we now have 3 columns in our table. We have the time in seconds and the X and the Y coordinate of our door handle. If we give a look at the Y graph, here we have Y versus time, and we see here a 5, a -5, but attention, this is not 5 meters. You see here a 10 to the -3. So this is actually 5 times 10 to the -3 meter, so it's ±5 millimeters. That's exactly what we expected. The car did barely move in the Y direction. If we look at the X graph, X versus time, we see that the distance is decreasing from 0 to -6. Y is the coordinate negative. You remember how we placed our origin. The origin was somewhere here, and the x-axis points towards the right, and the car is moving in the opposite direction. So the car is moving to negative x values, and that's exactly what we see here. If you find this disturbing, if this is bothering you, it's not a problem at all. We can simply bring up the coordinate system again. Let's jump to the end of our video and drag the origin to this point. And now, obviously, situation has changed. Now the car is moving towards the origin. It starts at a distance of 6 meters from the origin and is moving towards it. Now I want to know the speed of the car. One simple way to get it is to click on one of the labels and to choose another variable. I choose Vx, so the velocity in x direction. If I do so, you see, okay, this is 2.6, 2.7, so I drove at about the velocity of 2.6 meters per second. You see, in the first second I was slightly accelerating, but then I kept a steady velocity. You notice the second data point here is slightly off, and I'm going to check this in the video. I will click on this data point and go to the video. I zoom in 100% and check the position, and yes, you see it is slightly off. Let me zoom in even more. Yes, the one here is off, it's not on the door handle. Let's adjust it, and yes, that's better. Okay, now I want to know the exact speed of the car. The best way to get it is to do a linear fit on the data points in the xt graph. You probably remember from your physics lessons that the slope gives you the velocity. Okay, I right-click on the diagram, I choose Analyze. A new window pops up with the table and the graph. Now you remember I had a constant velocity after 1 second, so I choose more or less those data points. And now I click on Analyze, Curve Fitter, Line. Now the selected data points will be fitted with a fit equation of x equal a times t for the time plus b. A is the slope, and the slope is written here, minus 2.588 meters per second. That's about 9 kilometers per hour. Finally, we give a quick look at the acceleration. I right-click on the label, I left-click on the label and choose AX, the acceleration in X direction. And we see more or less this is what we expected. It's a value close to 0, so no acceleration. We were moving at a constant velocity. If you look very carefully, you can see that at the beginning, for the first second, the values are slightly positive, so I was accelerating. We have noticed this before. That's it for now. I'm planning to continue my work with Tracker and post more videos in the next weeks and months. So if you don't want to miss them, don't forget to subscribe and ring the bell. See you soon.